90%. Just let that number sink in for a second. 90%. That is the estimated chunk of Retrieval-Augmented Generation, or RAG projects, that literally never make it out of the prototype phase. Like, they look like absolute magic on a Friday afternoon, right? But then they completely break by Monday when they actually hit production. So, that brings up a massive, multi-million-dollar question. Why do so many AI projects fail in production? I mean, you see it all the time on social media. Someone builds this brilliant chatbot over a single weekend, it works flawlessly when they test it, and then crickets. Why does it just fall apart the second real users, real data, and real enterprise demands are thrown at it? Okay, let's dive right into this. Today's explainer is actually based on an absolute behemoth of a resource. We're talking about a comprehensive 7.5-hour masterclass published by FreeCodeCamp called Production RAG with LangChain and Vector Databases. We're going to distill the absolute core lessons from that exhaustive source material. Think of this as a shared journey of discovery, bridging the knowledge gap to take you from a fragile weekend prototype all the way to a hardened enterprise-scale application. Here's the mental map for our journey today. First, the RAG reality check. Second, building the vector foundation. Third, surviving production and scale. Fourth, establishing the security layer. And finally, the future of advanced RAG. We've got a ton of ground to cover to get you production ready, so let's jump right in. Welcome to Section 1, the RAG reality check. Basically, we're looking at the tip of the iceberg here. Moving right along to Section 2, building the vector foundation. Let's look at the indexing pipeline. Now, before we get into the heavy enterprise stuff, we've got to acknowledge the core mechanics that actually make RAG possible. It's really a highly elegant flow of data. Step 1, you load your documents. Step 2, you chunk them into manageable pieces, mostly so the AI doesn't get completely overwhelmed. Step 3, you embed those text chunks into high-dimensional vectors. You can kind of think of this step as assigning a very specific GPS coordinate to every single sentence based entirely on its meaning. And finally, step 4, you store them. The source material spends a really good amount of time detailing how to set this whole engine up using a local vector database called Chroma. All right, Section 3, surviving production and scale. It is officially time to face reality. If building that initial pipeline is just the visible tip of the AI iceberg shining in the sun, well, deploying it means descending into the massive, hidden underwater structure. There's a stark, undeniable contrast between basic RAG and production RAG. Basic RAG, that's tutorial-level stuff. It's simple similarity search and blind outputs where you literally just cross your fingers and really hope the AI isn't hallucinating. But true production RAG? Oh, that requires hybrid search, combining exact keyword matching with semantic vector matching for vastly improved accuracy. You're implementing token budgeting because, let's be real, calling these LLM APIs costs actual money. And crucially, you're using tools like LangSmith for deep observability that lets you see the exact trace of how the AI made every single decision. To scale this thing without your entire system collapsing, you absolutely need a firm grasp on these infrastructure choices. You need dedicated debugging systems and, frankly, a mastery of production visibility. You also have to face the real costs of vector search. The course demystifies enterprise hosting, specifically highlighting the necessary leap from a local tool like Chroma to robust solutions like Supabase using PG Vector. Why does that matter? Well, because PG Vector turns a standard, incredibly reliable PostgreSQL database into an absolute powerhouse that can handle massive vector queries without breaking a sweat. And more importantly, without draining your wallet. Section 4, establishing the security layer. We are officially entering the armor phase. So the absolutely crucial point here is this. You must set up and test a rigorous security checklist before deploying any AI application to the public. If the last section was about surviving heavy traffic, this is all about surviving malicious intent. A production RAG system running a fast API backend without a tested security layer is literally a disaster waiting to happen. The source material details exactly how to implement a LangGraph agent to act essentially as your security bouncer. This agent sits right there between the user and your database, actively checking for prompt injections, like a user trying to trick the AI into ignoring its instructions. It intercepts and neutralizes the threat before it ever even touches your core enterprise data. Which brings us to Section 5, the future of advanced RAG. Welcome to the bleeding edge. Now that our system is built, scaled, and heavily armored, let's kick off a high-energy lightning round on the frontier of this technology. First up is contextual retrieval. You see, the traditional problem with RAG is that when you chunk a document, the AI kind of loses the overarching plot. A single paragraph, isolated from its chapter, completely loses its meaning.
Advanced techniques now use what's called late chunking. This means the AI reads the whole chapter for overarching context first and only then zooms in on the specific paragraph you need, making sure the true meaning is never lost.
Next is agentic REG. Standard REG is essentially a simple one-way street. Retrieve data, generate an answer, deliver it. Agentic REG introduces self-correcting mechanisms. Basically, you're forcing the AI to grade its own homework. It's given the autonomy to evaluate its drafted answer. If it detects a hallucination or, realizes the retrieved context doesn't actually answer your prompt, it trashes the draft, adjusts its search parameters, and tries again, all before you even see the final output.
Then we have GraphRag. Instead of just returning isolated text snippets based on vector similarity, GraphRag structures your data as a beautifully connected knowledge graph. It enables multi-hop reasoning. For example, it can connect a CEO's name in one document to their company's earnings report in a completely different document, easily answering highly complex, multi-layered questions that would completely break a standard vector search. And finally, multimodal RAG. The source highlights Culpali, showcasing that the frontier of AI is moving rapidly beyond just text. This is vision-based document RAG. This means your system doesn't clumsily try to extract raw text from a complex PDF. Instead, it visually looks at the document exactly like a human would. It instantly understands the layouts, the charts, the graphs, and the images directly, retrieving information based on rich visual context. It's a real game changer.
We've covered an immense amount of ground today, transitioning from basic document loaders all the way to agentic security layers and multimodal reasoning. So as you look at your own projects and the data systems you're building, I want to leave you with this provocative thought. Is your RAG system actually ready for the real world? Or is it just another prototype waiting to become part of that 90% failure statistic? Take these principles of scale, observability, and security and start building the rest of the iceberg. Thanks for joining me on this explainer, and I'll catch you next time.